Have you ever tried to separate a big pile of mixed-up beads? Imagine you have a jumbled pile of beads. Red beads, blue beads, green beads. How would you sort them out? Maybe you'd pick them out one by one. That would take a long time, right? In science, we have mixtures of tiny molecules we need to separate. We can't see them or pick them out by hand, so we use a super cool machine to do the sorting. This machine is called an HPLC, High-Performance Liquid Chromatography. High performance, really fast and good at its job. Liquid, we use a liquid to help with the sorting. Chromatography, techniques that separate mixtures. The chroma part comes from the Greek word for color. Early methods separated colorful plant pigments. So HPLC is a high-powered method that uses liquid to separate different parts of a mixture. It's one of the most important tools in a modern lab. What kind of mixtures? Almost anything. Medicine tablets, to check ingredients and safety. Soda, to measure how much sugar is in it. Crime labs, to analyze evidence. It's like a superpower that lets you see exactly what's inside a substance. The HPLC machine turns a jumble into a neat, organized list of individual components. That lets us understand the world in incredible detail. So, how does this amazing sorting machine actually work? Let's go back to our bead analogy. Imagine you have a long, clear tube packed tightly with sticky sand. Now, you pour your mixture at the top of the tube. Red bead, blue bead, green bead. Then, you start pouring water through the tube to push the beads along. This is the basic idea behind HPLC. The process is like a tiny microscopic race. The mixture is our team of runners. The long tube is the racetrack. The liquid we use to push everything through is like the starting pistol and the wind at their backs. In a real HPLC, the tube is called a column. It's packed with a special material, very fine silica particles. This is our sticky sand. The liquid we pump through is called the mobile phase because it moves. The mixture is injected into this moving liquid right before it enters the column. Now the race begins. As the liquid carries the mixture through the packed column, the different molecules interact with the packing material. Some molecules are stickier than others. Smooth shoes, sticky Velcro shoes. Smooth shoe runners zip through the sandy racetrack and come out quickly. Velcro shoe runners keep getting stuck and move slowly. Different stickiness levels equal sign separation. Show beads separating into bands down the column. Less sticky exit. First moderately sticky exit, next stickiest exit, last. An HPLC system might look like a big complicated box, but it's really just made of a few key parts working together as a team. Let's meet the players. First up, we have the solvent reservoir. This is basically a bottle or a set of bottles that holds our liquid, the mobile phase. This is the juice that powers the whole system. It's like the fuel tank in a car. Scientists choose the liquid carefully because different liquids can change how the separation race happens. Next, we have the pump. The pump is the heart of the HPLC system. Its job is to push the mobile phase liquid from the reservoir through the rest of the machine at a very precise and constant pressure. This is where the high-performance part comes in. These pumps are incredibly powerful, creating pressures hundreds of times greater than a car tire. A steady, pulse-free flow is super important for getting good, reliable results. After the pump, we find the injector. The injector is where we introduce our sample into the system. It's like the starting gate at the racetrack. Modern HPLC systems have an auto-sampler, which is a robotic arm that can automatically pick up a small amount of your sample from a vial and inject it into the flowing mobile phase. This is great because it means scientists can load up dozens of samples and let the machine run them all on its own, even overnight. Finally, we have the two most important parts, the column and the detector. Columns come in many different lengths, diameters, and are packed with different materials depending on what you want to separate. The detector is the finish line judge. The computer then draws a graph, called a chromatogram, which shows peaks for each separated component. You might not see an HPLC machine at the grocery store, but its work is all around you, making your life safer and better. Think about the food you eat. Food companies use HPLC to check the quality of their products. For example, they can measure the amount of caffeine in your coffee, or the amount of caffeine in your soda, or the amount of vitamins like vitamin C in your orange juice. It's also used to test for things we don't want in our food, like certain pesticides on fruits and vegetables. Another huge area where HPLC is a hero is in medicine and pharmaceuticals. When a company makes a new drug, they have to prove that it is pure and contains the exact amount of the active ingredient it's supposed to. HPLC is the gold standard for doing this. Every time you take a pill, it has almost certainly been tested many times using HPLC. What about the environment? Yep, HPLC is on the job there too. Environmental scientists use HPLC to monitor pollution in our water, air, and soil. They can take a sample of river water and use HPLC to detect tiny amounts of harmful chemicals, like industrial waste or agricultural runoff. This helps them track down sources of pollution and make sure our drinking water is safe. Even in the world of sports, HPLC plays a role. Anti-doping agencies use HPLC combined with other techniques to test athletes for performance-enhancing drugs. This helps ensure fair competition in sports, from local competitions all the way up to the Olympic Games. So you want to use an HPLC machine? Let's do a virtual run. It's less intimidating than it looks. The very first step is preparation. Prepare the mobile phase, the liquid that pushes the sample through the column. Ensure the liquids are pure. Degauss the solvents to remove tiny dissolved air bubbles. Prepare the sample. Dissolve the sample in a suitable solvent. Filter to remove solid particles. Set up the machine. Place bottles of mobile phase on the instrument. Insert the tubing. Start the pump via the computer to flow mobile phase through the system and column. Let it run 15 to 30 minutes to equilibrate. Equilibration, it's the system's warm-up. Step 3, run the sample. This is the exciting part. If using an auto-sampler, load prepared vials into the tray. Build a sequence on the computer. Choose which vial to inject. Set the injection volume. Press start. The robotic arm will whir into action. It picks up the first vial. It draws a tiny, precise amount of the sample. It injects into the flowing mobile phase. The run is underway. Our work is mostly done. Now watch and analyze the results. As components leave the column and pass the detector, a live graph appears. This graph is the chromatogram. First, you'll see a flat baseline. Then peaks rise and fall as each component elutes. To wrap things up, it's clear that HPLC isn't just another piece of lab equipment. It's a true scientific superstar. Its importance comes from its incredible versatility and its precision. The power of HPLC lies in its 3 key strengths. Sensitive means it can detect incredibly tiny amounts of a substance. Precise means running the same sample 10 times gives almost the exact same result. Reliable. This reliability is absolutely critical when you're making decisions about drug safety or environmental pollution. The technology is always getting better. New columns that separate more complex mixtures, new detectors that can see previously invisible molecules. The HP in HPLC used to mean high pressure. Now it's more commonly high performance. Next time you drink clean water, take a vitamin, or trust that your medicine is safe, give a little nod to HPLC. It quietly analyzes, purifies, and quantifies the world around us. HPLC truly is a cornerstone of modern analytical science. Its impact is felt by all of us every single day.